Station, this is Houston. Are you ready for the event?
Houston Station, Luca on 2, I'm ready for the event.
Okay, Euronews, this is Mission Control Houston. Please call station for a voice check.
Station, this is Isabel Kumar from Euronews. Can you hear me?
Good morning, Isabel. I hear you loud and clear. How do you hear me?
I hear you very well. This is great. So I think we'll start in a few seconds from now. Just to tell you about the format, the interview itself will be 10 minutes long. Then we have some extra questions after. In the iTalk interview, we have video questions that we've received from our viewers, which will come in 3 different languages, but I will paraphrase those straight after. Is that okay?
It is great. Sounds like it's going to be fun. Can you hear me? Can you see me okay?
I can see you, and I'm very jealous. It looks amazing. So I think let's get going.
Explain what's all around me and behind me during the interview.
Fantastic. Yeah, if you've got anything, yeah, you can show us, and we're going to talk about gravity at one point, so if you can show us something that will make it very visually kind of clear to our viewers what you're explaining, that's great. But okay, we're going to start now. The next space station... Pardon, on se peut recommencer, excusez-moi. The next space sensation, making history hundreds of kilometers above our heads, Luca Parmitano is the youngest astronaut on a long-term mission to the International Space Station. The 36-year-old Italian blasted up to the ISS just a few weeks ago and joins us live from the orbiting outpost, answering your questions and sharing a rare glimpse of what life is like in space. Luca, many thanks for joining us on iTalk. I'd like to know, what's impressed you the most up there?
Well, it'd be easier to answer what has impressed me the least, because everything has impressed me. Living aboard the station is a very sensorial experience. Everything here is perceived differently. The things that we're used to take for granted don't apply here anymore. And so every time I look around is a surprise, is a different sensation. But I think I'm surprised. What's impressed me is how technology in the space station is really part of our daily life, but we adapt so fast that now it just feels like home, even though we are surrounded by technology and a very thin wall between us and space.
Okay, well, we'll go straight to our first question, and that comes from Belgium.
Hello, my name is Kelly from Belgium, and I want to know what has been the most difficult thing for you to get used to in space.
So there's been months of preparation, but what took you by surprise when you were up there?
Well, I have to say that the training that we get on the ground really does an amazing job of getting us ready for living up in space on the space station. The environment looks oddly familiar after spending years, literally 2.5 years, in different buildings around the world that where we have mock-ups of the station of this module where I'm living where I am right now. So we're actually very. It looks very familiar once you get here because you've seen it so many times. I actually was surprised. The thing that was really hard for me, however, was getting used to how things work different in zero G. What is easy on the ground, like staying still, is almost impossible at zero G. Things float all the time. It's impossible to put something somewhere. You always have to tether it or to attach it through Velcro or other means. So it's this reverse way of thinking where things that are easy on the ground are hard on space and vice versa. That was the hardest thing so far to adjust to.
Very briefly now, but how long did it take you to adjust to that?
I think I'm constantly adjusting to it. It's an evolving process. I've been on the station almost 3 weeks now, and I feel comfortable enough. I think that a 2-week span is what it really takes to start feeling completely confident about moving in a three-dimensional world and getting used to the microgravity environment.
Okay, well, Luca, we're going to go to our next question now.
Bonjour, je suis Grégory, je suis belge et j'aimerais bien savoir votre quotidien dans l'espace.
So you have got a very busy schedule up there. You're carrying out a lot of experiments. Can you briefly give us an outline of what you're doing?
So on the space station, at any given moment, we have hundreds, literally, of experiments. But we are only involved in a few of them at the same time. For example, today, my schedule is partly busy with the ATV, the European Space Agency spacecraft that just arrived a couple of days ago, actually yesterday. We're busy with some preparation, opening the hatch, which I just finished. As far as experiment, I am currently doing a diet experiment where we are trying to figure out, the scientists are trying to figure out how to reduce the loss of calcium. And my colleagues, I'm glad you asked this question because I have right here an example of what science we were doing today. This is an ultrasound machine right behind me, and today my two colleagues, Chris Cassidy and Karen Nyberg, were actually analyzing each other's spine through an ultrasound machine, and this will be a revolutionary way for people on the ground to be able to analyze damages to their spine in remote areas where MRIs or X-ray machines are not available. This is going to be a very big impact on the ground as we speak.
And there are some health issues up in space for you personally. Again, we're very short of time, but quickly, tell us what those are.
You're going to have to ask the question again. I missed the first part.
There are some health issues for you personally up in space. As again, we're very short of time, but can you quickly tell us what those are?
Sure. So one of the issues is the loss of calcium. Our bones need gravity to grow and get strong in a very simple way. If they don't experience that, the gravity, they tend to lose their calcium and to become brittle and fragile. It's sort of like osteoporosis. Another issue is at a cardiovascular level. Your muscles tends to atrophy because you don't use them as much. I don't use my legs almost at all while moving around in space. And the third one is related to vision. Because of the zero-G environment, eyes tend to change shape. That will affect long-term vision, even permanent.
Okay, Luca, we're now going to have a question from one of your biggest fans, and that's 5-year-old Alessandro.
Ciao Luca, mi chiamo Alessandro. La mia domanda è: pensi che esistono altri pianeti abitati nello spazio? Grazie, ciao.
So with the Kepler telescope, he's spot on, isn't he, Alessandro?
It sounds amazing. Yeah, he sounds like a great kid. So here's the question is, are there other forms of life on other planets according to me? So if you're ready for my answer, that would be my answer would be this, and this is Luca speaking, not the astronaut, just a simple person. I believe that there are so many planets, millions and millions of planets in the universe, that what we lack right now is imagination. If we could only imagine something different than what we call life, maybe not based on water, not based on oxygen, but on something completely different, maybe methane, maybe a different form of something comparable to what we call life, then I think that we're talking more of a probability than a possibility, and that's the simplest way I can put it.
Luca Parmitano, many thanks for joining us on iTalk. We now have got a few more questions from other programs, and one of those is for our Learning World program. It's on education, and we want to know, what was the most important milestone in terms of learning that changed the course of your life?
That is a great question. If I had to pick one moment that really changed my life, was when I was about 16 years old and I became an exchange student. I won a scholarship, go live for a year by myself in the U.S. as an exchange student. And I think that coming from Sicily, which is it's in the south of Italy, a little bit far away from the heart of Europe. That experience really opened my eyes and introduced me to the beauty of difference, the beauty of something that is culturally completely unrelated to what you're used to, and not to be afraid of social and cultural differences.
Okay, then I've got some questions from your colleagues. With the arrival of the automated transfer vehicle, you'll soon work on an experiment called PHASES. What can you tell us about this experiment?
So PHASES is an experiment that is related to emulsions. Emulsions are important because they have applications in many different fields, from pure chemistry to chemical industry to even the food industry. And as an Italian, that's specifically important. Emulsions have a tendency to be stable or unstable, and sometimes we want them stable, sometimes we want them unstable. On the space station, we have the unique opportunity to study them in an environment where their characteristics are not affected by gravity, and so it's an ideal place to study them in its simplest form.
So how can we benefit from this experiment?
Well, let's imagine a fuel. A fuel is basically a mix of different chemicals. Now, obviously, we will want this chemical to be stable for the longest possible, so that it can be stored, it can be used later in any condition, on the ground, in storage, on space, because of lack of acceleration of gravity. So if we need this fuel to be stable, we need to understand what are the characteristics that make a fuel stable or unstable, so that we can exploit those characteristics and accentuate the one that we like, eliminate the ones that we don't like. The same goes for storage of food, for example. A simple thing like a vinaigrette. Everybody has seen these bottles of mixes that separate after a while. Well, we need to. It'd be great if we could find a simple way to study these liquids so that they stay in a certain form, in a stable form, for the longest time. The same is true for the opposite. Sometimes we would like things to separate easily so that we can distinguish them. And again, the applications on the ground can vary from storage to a simpler way of separating, of cleaning. There's just certainly many more applications that I cannot think of right now. But those are just a few examples that I could give.
Okay, so you're participating in an experiment in September with Michelle Hopkins called Energy. Can you tell us briefly about that experiment?
Certainly, and it's sort of related to the one that I was talking about, the diet. In the future, we will try to understand how we can go further in space, leave low Earth orbit, and be independent. Well, in order to do that, we need to understand how much food, how much energy we spend as individuals when we are on orbit. So this experiment that we will do in September is going to determine exactly with a degree of precision that has never been attained before, exactly how much energy does an average cosmonaut use while in space. And that way we can predict in the future how much fuel for the body, how much food, how much water we're going to need to store in the spaceship in order to go for a trip, who knows, maybe to the next planet.
Okay, yeah, I think we have no more time, or maybe we could just quickly try and slip something in now. Can you explain what you drink? No? Okay, sorry, we're done now.
Station, we're out of time. This is Houston ACR. Thank you. That concludes the event.
And thank you very much, Euronews Station. We are now resuming operational audio communications.
In this time, this is lookout space to round 2. Copy.